John Powell the physics guy. John science is cool. John Powell the physics guy.
Are doing electrostatics. Welcome back to Unit 7. So what we will be learning about what is a charge and how do charges behave. For my students, we're going to have new seats. And good news is we don't need math today. So I know a lot of students get anxious about doing math problems. So what I'm asking here on the do now is I want you to draw an atom. Sorry, I have a very loud cat today. Label as many things as you can. Do you remember ever learning about what is in an atom? So again, doing electrostatics is a big switch from last unit, or all previous units. So everything we've basically done up to date was kinematics. Now we're doing electrostatics. So here I have an atom, and to be exact, I got 1, 2, 3, 4, 5, 6, 7, 8. I believe that's oxygen. I have an oxygen atom, and the atom contains 3 types of particles. We have the protons and neutrons in the middle, and all these guys on the outside, they are called electrons. I'm hoping you guys have heard about these things. So, unfortunately, my PowerPoint, these electrons were flying around in circles. It was really great. So electrons kind of orbit around the nucleus. Inside the nucleus, matter is made up of small structures called atoms. And at the center of each atom is a nucleus. And within the nucleus there are protons and neutrons, and they are so tightly packed in there. And they, very important, protons are positive, and neutrons have no charge, no electric charge at all. And the thing is, protons and neutrons never move. I'm going to keep repeating this. And then orbiting around the nucleus are called electrons. And you probably may have heard that before. Sorry, my animation's a little slow. Oh, come on. Oop. And boop. Electrons, they have negative charge, so these guys are negative. So because electrons are located outside the nucleus, they can be exchanged from one atom to another. So electrons are the ones that are moving. They're the ones that are changing, moving around, and gives us charge that's moving around. So if, say here, this sphere here gains electrons, we say it becomes negatively charged. That means it has more electrons than protons. And on this side, this metal sphere lost electrons. It now has more protons than electrons, so it becomes positively charged. So it's all about the number of protons to electrons. And normally everything, it's just neutral. They come in neutral. So that means they have the same number of protons and electrons. So in that case, there's no charge. I know an old chemistry joke about that. Okay. Protons and electrons have the same amount of charge. We say same magnitude of charge, but they are opposite signs. So, and we call them elementary charges, like the very smallest charge you can get, at least until we get to modern physics. So, it's the smallest amount you can have. So there's a negative for the electron, positive 1e for the proton, and of course 0 for the neutron. There's no charge. Lily, please. Charge is quantized, meaning there can be only whole number of charges. That means you can't lose part of an electron. You can't say I'm going to lend half of an electron there. No. It's got to be a full electron or not. So you can actually count the number of electrons that go by. So in this case, the left orb, there's 1, 2, 3, 4, 5 protons minus 1, 2 electrons. So this is positively charged by 3 elementary particles. And over here I still got 5 protons, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 minus 12 electrons. So I'm going to have a negative 7 E. Yeah, you can see what I did there. So I get a negative 7 E charge on this sphere. So again, when charge is quantized, that means you can count it in like whole numbers. And again, atoms cannot change, lose part or gain part of an electron. So in here, I had a neutral plate and it loses 1 electron. What does its charge become? Positive 1. Because you hear the word electron, you have to think, what is the total number of protons versus electrons? So this plate now has lost 1 electron. What happens if it loses 2? What does it become? 2e, positive 2e. And it loses a third, you get it, plus 3. Because this plate has a lack of electrons. There are more protons than electrons. It is positively charged. So now we're going to talk about the behavior of charges. Have you ever heard the term opposites attract? Well, it's similar to magnets. So opposites attract, like charges repel. So that means if I have a positively charged and a negatively charged, there's going to be a force that pulls them together. That's what the attraction means. And here I have a positive and a positive. There's a force that's going to push them away from each other. And we're going to talk about that force in a couple lessons away. Cheer up, guy. Electrostatics is the behavior of charges. In a charged object, the electron wants to enter or leave an object. So, in this sphere, when I have a bunch of negative charges, they don't want to be near each other, so they're going to distribute as far away from each other as they can. And if there's a way for the excess electrons to leave, they will. So if I bring my finger in and touch those extra electrons are going to come out, and we call this grounding. So all objects want to be neutral, just because the excess charges want to be far away from each other as possible. Now there's a thing called conductors. They allow charged particles such as electrons to move freely. Examples are copper, silver, aluminum, and salt water. So if you've taken chemistry, you would recognize that these are all metals. NaCl, that's the metal part. And metals are usually good conductors because metallic bonds allow for electrons to move around freely. So thermal conductivity is very similar to electrical conductivity. So like if you think about a frying pan, you ever seen a frying pan made of plastic or rubber? No, I mean it would be horrible. So normally you have metal for your frying pan because it's going to conduct heat very well, and your handle is going to be made of something else, like something not conductive, so that you can actually pick it up. Same if you want to keep your coffee cold or warm, you'll usually you can have a metal container, but it's usually a vacuum in between, and that's what's insulating it. So the next thing is insulators. Are materials that do not easily permit the movement of charges. Rubber, glass, air, and electrical insulators. Charge remains in the area where the charge was placed. So if you saw me doing the Van de Graaff generator demo with the balloon on the Van de Graaff, you can see that I'm putting all the charges on the balloon, but they're not moving. Otherwise, they would move onto my hand, and well, sometimes that did happen when I got too much charge. But they normally want to remain in the area where the charge is placed. So same thing, like if you have a thermos or like a cooler, they're usually made of plastic or some sort of insulator, and they do not move. So wait, I'm sure you've always wondered, why does this plug have 2 and this plug have 3? Well, the thing is, that third plug is the ground, or we call the grounding. It's the process of removing excess charge by touching a charged object with a conductor. Often the grounding object is connected to the literal ground because the earth disperses excess charge quickly. Like in my basement right now, I have a rod that's shoved straight down into the earth, and my house's wiring is connected to that ground. So if your appliance or something starts getting excess charge, which is why you see these big plugs often with larger electronic appliances, it has a way of getting rid of that charge and not shocking you or things around it. So it's a way of actually, just getting rid of that excess charge. So it makes it for safer objects. And then yeah, if you have some small appliance, usually they don't get too much excess charge. So don't worry, you're gonna be okay if you only have a 2-prong. I'm gonna talk more about that later. And I guess I can do these problems. Let's see. What is the net charge of a metal sphere having a deficit of 5 electrons? So, I already know it's 5e, but is it plus or minus? What do I have to think of? So, if it has a deficit of... It doesn't tell us, I guess. What is the net charge of a metal? Oh, it doesn't matter. So if it has a deficit, I know it's electrons, because they're the ones that can move. You can never have a deficit of protons. That means you changed your element. So it is plus 5e. This is plus 5e because it has lost 5 electrons. So what is the net charge of carbonate ion CO -2? So you haven't actually taken chemistry. So I mean, some of my physics students have, but this means it's missing 2 electrons. So you wouldn't know that. So plus 2e. Now, I always like to do, for number 3, if an object has this many protons and that many electrons, what is its charge? So I always like to do protons minus electrons, and then if you get a negative number, you know it's a negative, or if you get a positive number, you know it's positive. But you also just should ask yourself, what do I have more of? But anyways, I'm going to do this real quick. 8.28 times 10 to the 14 minus 6.26 times 10 to the 14. P and E. And I'm going to get 2.02 times 10 to the 14 E. I guess I shouldn't have wrote P there. These are all elementary particles. But protons, electrons, whatever. So this is positive. It is positively charged, and because I have more protons than electrons. Alright, so an object comes with a charge of plus 6e, comes into contact with an object negative 4e. What will happen after they touch? Okay, so this is a preview of the next one, and I actually haven't talked about this. Not really. So I have like these 2 objects. Oops, let me fix that. So I have these 2 objects, minus 4e, and they're gonna touch. So they're going to disperse their charges everywhere. So I know plus 6e minus 4. So I know the total is negative 2. And so I have a total charge of negative 2e if they touched. And they're going to disperse as much as they can. So I'm going to have negative 1e on one. Make clear. Negative 1e. And negative 1e on the other, because they're going to distribute. So I hope that made some sense, and we'll get some more practice in the next few lessons.